Hello, hello. This is Postgres FM. My name is Nik, as usual, Postgres AI, and as usual with me, Michael, PG Mustard. Hi, Michael.
Hello, Nick.
So we have a question today from one of the listeners, and it's about archiving. I have so many options what it can mean. Where to start?
Yeah, well, they specifically asked whether it was possible for us to do a video on archiving, and they said they want to archive a database that is about 5 terabytes in size. So what do you assume that means when you first hear it?
Well, if you are familiar with Postgres internals, and it's just not internals, it is about Postgres architecture. Archiving is simple. You just set up archive command, that's it, right? But it's a joke. I think this is not what was meant here. Though, yeah. So I think 5 terabyte these days is average size database. Who doesn't agree? Well, I see bigger databases, and 5 terabyte is not big database anymore. It was big 10 years ago. These days, big means more than 10 terabytes. This is just it. Right, so 5 terabytes is average size database, and archiving it means that we want to keep it longer term, right? How I read it. We want to keep it longer term, and or we want probably to clean up. Sometimes we want to archive, to clean up. Well, yeah. Because, for example, if imagine it's an e-commerce, we accumulated order history for many years. It's not used, but it's so much data. So why not archive it and then clean up? Clean up in Postgres, straightforward cleanup with delete, as we discussed many times, it's not an easy operation in large databases because of MVCC, vacuum, and all these complexities. So if it's partitioned, if bigger tables are partitioned, then cleanup is easy, right? We just detach and drop all partitions, that's it. And before that, obviously, archiving makes a lot of sense. But even if we don't have a task to clean up, archiving might make sense for backup purposes, right? We want to keep archive for long, or maybe there are requirements. Maybe there are requirements, right?
Yeah, I think there's an argument that it's slightly different to backups, but I'm not actually certain that how I've internalized that is helpful in any practical sense, because if you've got data archived, it's kind of a backup, right? Like it is another source of old data. But I do think they're different in that you wouldn't expect an archive to have up-to-date data, whereas you would expect a backup to have up-to-date data. So I do think there's subtle differences. And also I think you back up and you archive for different reasons, therefore there's different trade-offs. So if we're backing up in order to be able to get back online quickly if we have a disaster, that you might want to put it somewhere different in a different format than if we archive it because we need access to it, but not necessarily performantly.
For me, in real life, for example, take our DB lab or experiments. Experiments should be done on clones, right? On thin clones, on branching, if it's DB lab, for example, or full-fledged clones on separate virtual machines, if it's self-managed, right? And we say, let's restore either from cloud snapshot of disk, or let's restore from backups or from archive, and there it's purely synonyms for me. Let's restore from archive. And that's why archive command, it's a part of backups, right? It's archiving walls. And we say we have many versions of our database, not versions, many exemplars of our database in archive or in backups. Backups, archive, it's the same for me in this case. And of course we want to be it quickly restored, but these days, if it's cloud, it's easy to configure. So you basically archive it, back it up using PGBackRest or WolG. It goes to S3 or other object storage like GCS, or I'm not an expert in Azure Blob Storage, they name it, right? And there you can configure it so, for example, a couple of weeks later, that backup automatically moves to colder storage. Like in S3 it's called Glacier.
To an archive.
Well, all our archives, one is
Yeah.
hotter, another is colder, right? It's Glacier, or like in GCS and Google Cloud, it's called Cold Line. I don't remember the name. But the idea is it's cheaper,
Yeah.
but slower to restore.
Yes.
And this still causes a bug which is known many years in WolG. I recently wipe coded a fix because it changes modification time, and latest becomes broken. If you want to restore using uppercase latest with WolG backup fetch latest. In this case, it will fetch might fetch wrong backup because it's based on mod time, modification time, and if when it's moved automatically to colder storage, modification time of old backup old changes, so latest might be broken. I recently I sent it to Andrea already, pull request to fix it in WolG. It should be fixed, right? Yeah, but I mean, modification time cannot be trusted here, obviously. So,
Sure.
yeah, but it's a good idea, and it's great that clouds support this. Super easy to you just configure some policy, how long to keep them, how long to when to move to colder storage. So it allows you to, for the same money, to keep archives for longer, right? So,
Or if like, for example, you're doing this for compliance reasons and the length
right,
of time is predetermined how long you have to keep it for, you can
right,
keep it for that long for cheaper. Like that, it feels to me
right.
like that's the more, yeah.
Yeah, so obviously it's not SSD anymore, it's HDD, but it's still super reliable. And as I understand, they promise a lot of nines, like amazing number of nines, 11 nines or how many? It's like
But here we're
basically
talking about durability, not like availability, right? Yeah.
exactly. So obviously data won't be lost. That's the
Yeah.
key. And it can be stored years if you want, right? And that's great. The only risk remains if somebody possesses your cloud account access. They
Yeah.
might destroy everything. To protect from that, there is a lock option, right? You can lock and basically say you cannot delete. Nobody can delete, or you can copy to different account or even different cloud.
Yeah.
Right.
With
So
different permissions.
right. Right, and if it's if it's backups using PGBackRest or WolG has a special command for this copy, so you can copy from one backup location, one archive location to different archive location,
Yeah.
right? But if you are on managed Postgres, in this case, physical backups are not available unless it's Crunchy Bridge. Right, which is great that they allow it to access physical backups and
Yeah.
vaults. And in this case, the only option remains is to create logical backup, which I prefer to call dump. And we had an episode: is logical dump, is logical backup a backup? My answer is still no, because backup
But
without okay.
is it an archive? Because I think like archiving almost always isn't incremental, right? Like you do it in batches, right? You take a whole year and archive it. So in this case, it's not changing. So a logical dump is an archive.
Well, for me, again, like I don't feel this difference. I hear you feel some difference, but for me,
Yeah.
all backups are also archive. They're just continuous thanks to wall archive. They consist of
Okay.
two parts: full or like deltas, incremental, differential. There are many names additionally there, but basically, like full copy of data directory plus walls, right? And walls make them like continuous. This archive becomes continuous.
This is where I think we have a difference, because I think these. Let's go back to the question, right? They want to archive a database that's 5 terabytes in size. That's all the information we got.
Yeah.
But we don't, like, there's a chance that it's an old product that's no longer served and they just need to keep the data for a certain amount of time. It could be that it doesn't need to be accessed anymore. It could be all manner
They
of
maybe
things, right?
want to drop. They maybe want to drop database and just keep it for history, right? So to answer this question directly, the first thing we need to understand, is it managed service or we have access to physical level?
Yeah.
If it's managed service, the only option for us is pgdump.
No, I disagree.
Why?
Well, because I think you could. So, depending on the parameters, right? Like, you could export it in a different format, right? There's a lot of of work.
Logical backup is the only option here. Okay?
Yes.
Although technically speaking, we can rely on. Okay, we can say, okay, let's create a snapshot and consider the archive and rely on RDS that they will keep it for longer. Why not?
Yeah, but so here's what I'm thinking though, and 5 terabytes is not very large, right? As you were saying at the beginning. But if in the general case where we care about cost, it seems like cost actually matters here. It's one of the main reasons for doing this in the first place. If we care a lot about cost, it feels to me like some of the newer formats that compress extremely well, like, and maybe new is not the right term, but it's new to me in terms of coming across it from a Postgres perspective. But the formats like Iceberg and Parquet that compress down extremely well feels to me like would be the cheapest way of archiving data that's static and is not going to be changing, or you're going to get a new batch of it once per year. Like the archiving use cases that I'm thinking of, if we exported in those formats, they'd be tiny. Like the 5 terabytes might go down 95% or so.
Oh, I doubt. 20 times, I doubt. Well, maybe. Okay, what have you seen?
Yeah, I've seen people reporting that kind of, like, even on the timescale compression side, I've seen that reported, and that wasn't even
depending on data again.
Yeah, it depends on data, right? But if you've got a lot of columns that compress, that have a lot of similar data in them, which I think is pretty common, especially for, like, if we're thinking it's healthcare related or financial, like transactional data, a lot of that is numerical stuff.
Well, okay, Parquet is interesting. I think it's an option as well, and in this case, you can also, like, it depends on access patterns later, right? We need to first thing we need to answer: do we have access to physical or only logical? Logical, we obviously have access because this is our database.
Yeah,
I suppose. Right. So physical versus logical thing, we discussed it many times, but physical also can be compressed, right? So both WAL-G and PGBQS, they compress data directory and WALs. So why not?
Yeah.
The only thing super important thing to remember is that you cannot just take data directory, that's it. You need to make sure WALs are also archived. If it's only logical, okay, there is a Parquet option, but also there is a pgdump option, which also has compression.
Yeah, but we're not getting this is compression like at the page level, right? Or kind of the row level. And I think column level compression is hard to compete with.
Well, it's page level or file level?
Okay, what's the difference?
There is difference. Huh. Well, from pgdump I would expect 10 times sometimes. In some cases, 10x compression. If you there are options in pgdump, right? ZSTD I would check definitely, and it has. Do you remember if pgdump allows to control compression level? Can you set compression level 19? It will be terribly slow, right? Or if you check,
we might be okay with that that's the nice thing, like about this use case is we might be okay with really slow retrieval, really slow restores, because the main point is keep it for many years.
Right. Anyway, PageDump supports for multiple years already. It supports options, and you can control compression level there. You cannot control compression level in wall compression, which compresses full page writes inside, full page images inside wall, right? There, it was my proposal. I need to finish it. There you can control algorithm, but not the level of compression.
Sure.
I'm not sure everyone needs it, but still for completeness, we should support it in Postgres, right? But for PageDump, definitely you can control level. So if you are okay to wait and load CPU a lot, and it will, like in some, if you check ZSTD 19, I think it should be super slow, but maybe beneficial for in terms of size. And of course, restore will be also slow, right?
Yeah.
Yeah.
That, I think that is something to factor in if people are deciding which way to go, though, is what kind of questions are you going to get of this old data? Like, are there going to be auditors that want to come along and be able to query it? Does it matter that it takes, like, if you're going to get advance warning that they're coming, does it matter that it takes a day to restore? Are there going to be analytical queries? Like, are people going to want to know aggregations on it? Because then if it's going to be mostly aggregates, maybe you do want it in some columnar format where you can get those done quickly.
Well, you confuse me, but obviously when you compress a dump, it's file level, so the whole thing is compressed. It's not page level.
That makes sense, yeah.
So it should be good. Page level, if it's for example you store something on ZFS, there it's page level. Not here, no. The whole thing is compressed. It can be super slow, of course, but quite well compressed. Not sure how it will compete with Parquet. I have not a lot of experience with it, so like in production. We have a customer who has it, self-managed database and archived from time to time in Parquet format.
Yeah,
and it's great. Yeah, it works. It also ZFS. It's interesting setup. But anyway, I think there is a potential here if somebody wants to write some article or do some research. There are many options to discover here and benchmark. Like we could build some, like decision tree. Like do we like physical or logical? How to decide? I would stick with physical always if recovery time matters and if we want continuous archiving, right? If we have access, of course, because if no access, it's blocked. This path is blocked.
Yeah.
Logical, okay, dump or Parquet format. Dump, we have compression options. Definitely, I would choose. I would not choose a single file. Well, again, depends, right? But normally we choose custom format because we want compression and parallelization, right? Because if you want single file dump, then you cannot use parallelization, and you will be limited by a single vCPU work when dumping and restoring. When you use custom format, you can say how many jobs, how many vCPUs to utilize when dumping, and separately when restoring. It can be different number, and this matters a lot if we want to dump faster and restore faster, right? This thing, and then so this is the decision making tree, right? And then finally, where to store it? Is it definitely archive shouldn't be stored on expensive SSD disks, right? It should be stored. Object storage is great if it's cloud, right? If it's not cloud, some cheap disks which we don't use a lot, so they like serve as archive. Or even like, is tape still an option? I think in many organizations, which old organizations still has tape. Well, it has a huge lifespan, right? So tape, right? Why not? Anyway, it should be something which we know is reliable, will live very long, right?
Yeah.
But also we need to take into account the restoration timing, right?
Maybe, yeah.
Because Glacier super cheap. S3 Glaciers, like the cheapest, but also the slowest to recover from, right?
Yeah.
To fetch data, fetch data from there. So it's interesting, right? And physical backups also can be, physical archive also can be placed into various locations. So location question, I think it's a separate decision.
Well, yeah, I think there's a couple of other things to factor in, because if you do store it in Parquet, for example, you can query it without restoring. You don't even have to restore to get the data.
Yeah, that's great option. Also, logical dump path is great because it allows you partial archive. If you want only specific tables, right? And also, of course, you need to take into account that you only archive data, no helper data. Helper data is indexes or materialized views, so derived things, which means that recovery will be longer, right? So I would say if you are going to drop some database for historical purposes, even if you have a physical access, I would probably do dump still. 5 terabytes dump, if it's powerful machine, definitely within 1 hour, definitely, but
Yeah, we talked about it recently.
Local. Yeah, and if it's like with many threads, you can. Well, if it's a. By the way, dumps are always interesting. I think it doesn't matter Parquet or native PG dump. If you have unpartitioned case and, for example, 5 terabytes, but 4 of them is a single table. We see it a lot actually. One huge table, usually called logs or history or something like historical events, yeah. Sometimes queue-like workload, yeah, but something like accumulated, and then people think how to get rid of it. Partitioning is needed there, right? Because without partitioning, dumping will be single-threaded as well. Although you could create your own tool, and I think actually pgdump could support it using ID ranges. Dump using multiple parallel threads. Well, theoretically it's possible and you can write this, but out of the box pgdump will limit you, and probably dumping 5 terabytes will look like this. And you say I want like to utilize all my 16 cores and using 16 threads to send it to S3. First 10 minutes all 16 threads are utilized, and then a couple of hours just single thread is working because one huge table.
Yeah.
That's why. So partitioning would become archiving much faster and more flexible to tune. Like let's move faster, because again, if it's live database, every time we archive logically, we have long-running transaction. And we affect vacuum behavior, even if it's on replicas which have hot standby feedback on, right? So this can lead to higher bloat and various negative consequences.
I don't see it as much anymore, but I used to get quite frustrated seeing partitioning advice that mostly focused on like the read performance benefits of partitioning. And the more I've learnt about it over the years, the more I think the main reason to partition is for these maintenance tasks and for health of the database overall. But time-based in particular, if you've got an archiving requirement, if you're ever going to need to remove data based on time-based partitioning is just a dream.
Yeah, you're absolutely right, as some LLMs say.
Okay, yeah.
Right. So exactly like this, archiving, restoring, like dump restore, how vacuum works, how index creation works. Even physical backups benefit from partitioning, because if updates, insert, deletes are localized to specific files, so Postgres keeps tables and indexes and files up to 1 gigabyte. So if it's 5 terabytes, 4 of which a single table, it will be shrink to 1 gigabyte files. And Imagine we have a single unpartitioned table. All writes can come to any of these files all the time. Any blocks inside, any pages, all the time. Like it's not localized, right? And in this case, if you use snapshots, RDS snapshots, they have incremental support, right? So first snapshot is full, and then next snapshot is just diff at block level. If you use VolG or PG backrest, they also have delta backups or incremental backups or differential backups, where also at block level only changes are backed up, right? So in this case, if you have a huge table you write constantly everywhere, your delta will be bigger compared to the case when you write only to specific file, which is like our latest file, and only occasionally you write to old, updating old data, all the records. In this case, these deltas will be much more localized, and this is also beneficial, right? So even physical backups will benefit from partitioning. So general advice, yes, and our general advice was always, if you exceed 100 gigabytes one table, it's time to partition. People ask, is it counting, like, do we count it with indexes, with toast, well, without? Well, it's very, very rough number. So recently we started saying, okay, if it's exceeding 50 gigabytes already, let's think about partitioning, right?
Yeah.
Without indexes, maybe,
The point is, don't worry about it if your whole database is 1 gigabyte, but also if your whole if your largest table is already a terabyte, maybe it's a good time to.
It's late.
It's like you know what I mean. That like that's the reason for giving a rule of thumb is give people an idea of where they stand roughly, and if you're close to that number, be thinking about it already.
So we have funny stories when AI companies come to us for help because they grow too fast and they need help.
Yeah.
They lack database expertise. We have a bunch of AI companies, AI startups, and it was an interesting story. So some company like achieved like between 10 to 20 terabytes already, and they have tables exceeding terabyte, and someone from our team says that they should partition a year ago, but I said I just launched a year ago, right? So the pace is very very high, and I think Postgres needs improvements in the area of partitioning to simplify how like developer experience, and I hope we will work in this area next year with our tooling.
It has got a lot better at native partitioning. It feels like maybe not 18 as much, but it feels like most releases before then, since it was introduced, there was like significant improvements.
Right.
Maybe there were in 18 as well.
In terms of areas like detached partition concurrently, in terms of support of online operations, locking things, but still it's super painful. Still.
Yeah.
You know, like you need to allocate an engineer for a month or two to implement it. And we have great guidelines which we give our clients, but still lack of automation.
You mean like to migrate from non-partition setup to a partition setup? Yeah.
The hardest part here is that everyone is using various ORMs, and like they want this tooling to be closer to their language, right? There is of course PG Partman, but still.
Oh, okay. It's about the creation of new. Okay, interesting. Yeah.
It's about creation of new partition and then maintaining it, because when you have partition schema already, there is amplification on several risks. One of them very well known, log manager, right? And I had a series of blog posts recently studied Postgres 18 deeper, also in context of prepare statements, and it was interesting. And another thing is that any DDL schema changes, they might be really painful, right? Even simple index creation or dropping index can be painful, or foreign keys, right? So it requires every time you need, like every time we see it, like people implement some nuances, and it feels like Postgres needs to solve it.
Fair. All right. Anything else on the archiving front?
Final thing. If you archived something but haven't tested, right?
It's like backups, right?
Yeah, Schrödinger.
When we say tested, you mean like, can it be
Restored.
restored? Can it be queried?
Yeah.
And
Yeah.
also, is it the same as the data it was originally? Like, it's not, it's verifying it as well, right? Like, you do some basic checks.
Exactly. So unverified, unrestored backups and archives are like undercooked.
Yeah, great point.
Just simply undercooked, and should be considered as a huge critical mistake. That's it. Huge
and a risk,
critical
right?
mistake.
Yeah.
Yeah. So if you did something but never run, if you write a code but never run and ship, how
Yeah.
does it feel? The same with backups. You created backup but you haven't tested them. Archives, yeah. So it's a critical mistake. That's it.
Nice.
This-
Good addition.
Yeah. This addition, yeah, just almost overlooked. Yeah. Okay.
Yeah. Nice. Well, thanks again, and catch you next time.
Bye bye.